Hi, my name is Vishal and I'm an academic staff with the Professional Officers Division, POD. Today, I'm going to talk about our Robotic Systems Program, RSE. RSE is a specialized engineering program that focuses on the systems engineering of service of field robotic systems through the use of software and artificial intelligence as integrative elements. This program is centered around the systemic development of service of field robots, where different engineering disciplines are integrated around this central theme. We look at the creation of robots as a system related to its environment rather as opposed to an isolated robot. The program focuses on two fields of study. The first focus of the program is on service of field robots. These are robots that are not mounted in a controlled environment within a factory. These robots operate in service of humans in the fields. Examples of these robots are shown here. They include a four-legged robot, NASA's Curiosity rover operating in Mars, and a cleaning robot. The second focus of the program is on systems engineering. Here we look at the context surrounding the robot in operation. The context includes the operating environment, the human interactions, the infrastructure, and other elements. In terms of depth and breadth of coverage, first, we have robotics engineering that provides the technological depth in terms of robotic skills and expertise. Here, students start off with fundamental mechatronics to build up the foundational structures for their robots. Mechanical engineering, electrical engineering, electronics engineering, and computer engineering are integrated and applied here. With this foundation, advanced robotics topics such as robot navigation, robotic manipulators, and any effectors are covered to provide the basic structures with different functionalities. Throughout the development of these robotic systems, software is used as an integrative element that fuses different subsystems with AI, providing the processing capability for intelligent behaviors eventually. Then we have systems engineering. Systems engineering provides the breadth to collaborate disciplines with experts in other areas and to apply knowledge in areas of expertise other than one's own. Here, the robot is treated as a multidisciplinary man-made system that exists within a larger context. The emphasis is on the interrelations between the different parts of the system, such as the business environment that drives the needs and requirements of the system architecture that drives the integration of different subsystems, the validation and verification of the system as a whole, the interactions with humans, and finally, the interdisciplinary integration of different technical fields. In summary, we are using robotics as a foundation to build depth in terms of software development and breadth in terms of systems engineering to produce a holistic program. Next, I want to talk about how we build robots from an industrial perspective. First, we have a platform that provides the basic functionality. Here, we are using Spot from Boston Dynamics as an example, the yellow robotic dog on screen. As we need the platform to perform different functions, we add on different subsystems which can be seen at the top of this image. If we need to extend the functionality of the system, we will need knowledge in mechatronics to build up some subsystems which can be seen in the images at the bottom right. Once everything is connected, we need software to link them up to provide basic behavior. If we need intelligent behaviors, we deploy AI and machine learning technologies to act as the brain of the robot. Robots that are constructed need to be deployed into their operating environment. This is the next focus of the program. Here, we look at system integration, how to integrate different parts from different domains together. We are also focusing on the life cycle of the robot, where we look at the impact on the context surrounding the robot as it gets created and disposed of eventually. Some of the topics that are covered in these aspects of the program are listed here. Software development is a key part of the program. We start training for software development from scratch and progressively move towards advanced topics. Students will start with fundamental programming and move on to advanced topics such as artificial intelligence, and machine learning. Some of the topics that are covered in these aspects of the program are listed here. The Robotics Systems program incorporates a significant amount of project-based learning activities within its project modules that connect academic knowledge and skills with real-world applications. There are two distinct types of project modules, both involving active industry engagement in their development within the first 2 years. The first type is mission-focused and integrates interdisciplinary knowledge to develop systems for mission-related tasks. The second type is systems-focused, which emphasizes learning of the robotic systems development processes. These projects allow students to simultaneously experience systems engineering, project management, and systemic integration of knowledge from multiple disciplines. In the third and final years, students are required to complete projects that serve as the culmination and integrative experience of the program in their integrated work-study program and capstone. Lastly, I want to answer the question, what can a student do after graduating from the program? We have to start with the anticipated demand for robotics engineers. New demands caused by the COVID-19 pandemic is bringing about a surge of robotic applications as companies automate their operations to deliver more value. Accelerating applications of robots after COVID-19 is critical to both recovery and future economic growth of Singapore. Examples of this can be seen in the rapid application of robotic systems as shown. Companies such as those listed are actively deploying robots for automation, applications which we have seen in the previous slide. When we did our industry scan, we spoke to these companies. They have indicated that they are actively looking for robotics engineers with the skill sets we described previously. This gave us the confidence that graduates from the program will be well sought after they have successfully completed our program. With that, I will end my presentation. Thank you.